All right. Good morning, good afternoon, good evening, everyone. Welcome to the 20th Filecoin Core Devs meeting. It is Thursday, June 17th. I'm going to drop the agenda in the chat. Might be a fairly quick meeting today. It's mostly updates from the teams and then some more discussion around Network V13 Actors V5 and kind of the timeline and some testing and simulation work that we've been doing. And obviously, if there are other agenda items, we will take them on. But first off, let's jump into updates from the various teams. Maybe let's hear from Venus first.
Hi, everyone. Yeah, this is Steven from Lotus team. Yeah, in last 2 weeks, we had something about Venus. So the first thing is that we had successfully integrate the Speak Actors V5, and also load the Venus code into the calibration network, and it works fine. Yeah, so far so good. And another thing is that we completed the first version of another component we called Venus Gateway. As you know that we have some common services for Venus for the distributed mining pool. So for all these common services, there might be some access point for each component. So we have another component called Gateway to combine all of them to let all the miners will have a uniform access point. It will make things easier. This is another thing we have done, and we also put the gateway into the live pool, live pool in the mainnet. Also, so far so good. Another big thing is that we are working on the documents upgrading. So if you go to the Venus Filecoin document, which is already polished, and it's much better, I would think, that than ever. And I can put it in the chat window, if you want to check. And we also have another README file to make it clear about for people if they go to GitHub to see the Venus repo. And we're also working on an FAQ, which is in progress. It's because we're preparing for the Venus mining incubation center. We're preparing for that, and we plan to launch it in July. So we want to have some small miners to know the details how to connect it to our common services. I think that's what we are working in last 2 weeks, and in next 2 weeks we will do more testing and review the new code to make sure that the upgrading to the new network version is successful. About the upgrading. Another very big thing is that we want to complete all the fixes and against the issues found in our audit. So we want to complete all the want to have the final audit report in next weeks. I think that's all. Thank you.
Excellent. That's a lot. You have a lot of parallel tracks going on at the same time. It's great. Very, very cool to hear that the Venus nodes are running well on calibration net and are kind of ready for the hyperdrive upgrade on mainnet. And also very nice to see some of that like docs work and kind of user experience work. For the benefit of anyone viewing the recording, the docs link for Venus is venus.filecoin.io. So check that out. That's very cool. Any questions from anyone about it? Cool. Let's run into Forest. How are y'all doing?
So some exciting stuff going on. We got a preliminary report for our audit last week, couple weeks ago, something like that. So we've been working hard on fixing, a bunch of the stuff. Doesn't look like anything requires any big refactors, thank God. So yeah, we're getting those fixes in. We started working on the Actors v5 changes. So currently updating the runtime and integrating the new proofs libraries, and then we're going to start implementing the FIPS. Should be done relatively soon, I would say. We should have been starting this a little bit earlier, but it was kind of unclear when the preliminary report for the audit was going to drop. So when we got it, we were like, oh, we dropped everything and started working on that right away first. So there's that for V5, and then we got metrics landing in like probably in a couple days or so. We got some cool little Grafana dashboards going on, just to get more insight into the nitty gritty of the performance and stuff. We've successfully refactored a lot of our RPC stuff, and so now we're moving quite fast with implementing a bunch of CLI commands, and that leads to us, starting to write user documentation and prepping for our first release, which I don't know when it's going to happen, but after we get all this stuff in, I guess. Yeah, I think that's it.
Nice, sounds good. Yeah, sounds like you're in a putting the finishing touches phase, which is great. And yeah, let us know obviously if you have any issues with V5 actors, V13 upgrade. There's a bunch of stuff from like test vectors, which I'm sure Zen will talk about, but also interop.net, and it's not running on calibration net as well. So you have lots of resources to test against. Cool. Any questions for the question? Okay, let's hear from Fuhan, please.
Thank you, Yush. Good morning, evening, day, everyone. So we finally have some great news. We were been able to resolve all the memory management issues, and now the memory consumption seems stable. Well, small deviations of about 20 to 30 megabytes happening, but that's totally okay, and it's coming back. So at this point, I think we will. Well, the node been running for 2 days now, straight away, no issues, no memory management issues, no sec faults. So we will let it run for at least 1 more week, and well, if something will happen, we will try to fix this as soon as possible. Otherwise, I will hit someone from the foundation to set up the security audit, and we will be preparing for the testing of miner on interop.net. This is something we have had to postpone due to like investigation of the memory management issues. And we have also introduced a couple of improvements internally. So we have introduced the proper chipset caching for certain components, and we have refactored the API. Well, actually, the main memory leak was related to the API, how the messages are transferred to the API. So this is something we had to change. And I think that's mostly it for the changes we have been doing past 2 weeks. So yeah, I think that's it.
Good. Congratulations on finally getting those memory leaks all plugged. I know it was a lot of effort and a long time coming.
Yeah. Unfortunately, yes, but hopefully it will happen in the future. At least I hope so.
Yeah. Hopefully.
Hey.
Yeah, sounds good.
Would you mind if I interrupted a bit, Ayush? So this is Dudley from Filecoin Foundation Security here. Did I understand correctly that you guys are ready for an audit now?
Yes, you do.
Okay,
So,
I'll reach out to you after this, and we'll work on getting a contract and seeing if we can find auditors that you would prefer in the timeline.
Yep, sure. Thanks.
Fantastic. Any other questions? Cool. All right, so kind of for the Lotus side of things, maybe Zen, do you want to start kind of with like our final actors release candidate, and then we'll bubble up from there?
Yes. So I'll link you to the V5 RC3 tag in the Zoom chat. And if you're watching this, you can just go to the Spectactors repo and click on tags. There have been very few changes between the last time we spoke and now. There were a few bug fixes, which you can take a look at. I won't get into. The biggest tweak to behavior is checking the caller addresses on the proof commit aggregate method based on some security concerns. So other than that, all behavior should be the same. So the only other thing I have to report on from the Spectactors side is the generated test vectors work stream. So now on Spectactors master, we have auto-generated test vectors from scenario tests. And I'm linking you here the README in the repo, which explains how to get these vectors for running against existing test harnesses in your own projects. I'm also available on Slack to help make sure things are working, figure out how to use these. But I'm really excited. I hope this makes development a bit easier. And that's all I got.
Fantastic. Yeah, I'm sure anyone re-implementing actors is going to be very happy to have those test vectors. Cool. Yeah, so kind of from the Lotus side of things, we have consumed the latest, so that actors V5 RC3 did and are obviously implementation complete in terms of the hyperdrive upgrade. Did a bunch of testing on kind of internal test networks, and it's running on InterruptNet, and didn't find anything too concerning. And so we put it on calibration net. The calibration net has now upgraded to V13 and is using V5 actors, running well. We did find one proofs deadlock, or it was deadlock in Bellperson actually, which was causing some nodes to stall. That has since been fixed with potential performance ramifications that we're still investigating, but we're not too concerned. Yeah, and so if you are at all interested in trying out the functionality unlocked in FIPS 8 and 13, you can do so on calibration net. The latest Lotus release is kind of RC5. We're on RC5, but most of the release candidates have involved like very small changes, like minor fixes or oops, we based off the wrong branch, that kind of thing. So we're generally feeling like RC5 is pretty stable at this point, and you know, not too much scary stuff has been uncovered, which is great. Miners are really testing on calibration net pretty hard, so we're waiting to see kind of the data that we get from them, and that'll be like the final piece of confidence building that we want for hyperdrive. But if things continue to look good, we'll probably be shipping a release sometime next week, with the network upgrade itself being 1 to 2 weeks after. Figure out the exact timeline. Yeah, so that's kind of what we're thinking. There's also been some interesting results from some predicting the future work in terms of simulating what the world will look like after hyperdrive, but we'll get into that. Stabilian will be talking about that. We'll do that after updates. That's the first item on the agenda. Any questions to any of that? Cool, sounds good. All right. Any updates from the foundation or from the community side of things that we'd like to share?
Oh, hi. Sorry for joining a few minutes late. I did want to just quickly share that we launched the miner working group this week. For all of those that are not as familiar, this is something where we have miners representing North America, Europe, and also Asia, have a forum for them to talk about some of the challenges. We're also hiring someone, I think I mentioned in previous calls, for a miner advocate role to really be a voice for the ecosystem. And so a lot of what comes out of the mining working group will feed into how we think about grants that we fund from the foundation side. We will help think about programs and additional incentives that might be challenges in the ecosystem. And let me go ahead and also share the blog post for those that may not have seen it. And then I'll also let Sonia fill in on other other things from the grant side. So give me one sec. Here we go.
Cool. Quick question about the minor working group. What are kind of the immediate priorities for the group?
Yeah, so this is really something that is led by the community, not us at the foundation. And so we're going to hear, we just had a kickoff meeting yesterday. We're going to really hear the top priorities, but a couple of areas that we've heard so far are, everything from client deals to some more compliance questions around data storage. And then there have been a lot of discussions around other issues like retrieval mining. There's a lot of people wanting to learn more there. So we definitely want to make sure that everyone in all geographic areas can kind of talk about top priorities, because obviously there's a huge size difference. And so from there, we can kind of narrow down how we think about being able to propel some programs that fit those needs. So
thank you. Yeah, Sonia, D or Dudley, updates from you folks?
From the community, yeah, I mean, thanks for the great update, Clara. I mean, from the community end, I think a lot of what I'll be focusing on in collaboration with a lot of you is just trying to find better ways of incorporating community feedback into the FIPS process itself. I mean, while we're still waiting to get someone who can focus on governance itself. I know this is something that has been brought up in previous conversations. I already mentioned that I did go through all 19 of them. And I know there was the whole conversation about should the community be involved in deciding the timelines for network upgrades, etc. So I will be reaching out to a lot of you to kind of pick your brain around how we can get the community involved in a lot of these processes. Something else that I also want to kind of pick on is the track record of how the community has responded to a lot of the FIPS that we've already implemented on the network itself, to kind of assess the impacts that the FIP process is having, not just on miners, for example, but on ecosystem DAOs as well. And something else that I will be having conversations around is the developer portal that we're trying to build. So getting your feedback, getting your opinions on what should go on a developer portal that can make it easier for developers to get started with each of these implementations. So I'll reach out to you, Ayush, and then we can take a conversation from there and spread it out to all the other implementations.
Yeah, fantastic. That sounds very interesting. Yeah, thanks a lot for kind of going back and trying to draw insights from the protocol changes and FIPS that we've made on the network so far. Because I think this group kind of moves very quickly, and we want to get things out there. But there's probably lessons that we could have drawn, or insights that we should be drawing that'll be very valuable. I think that's really cool. Thank you.
Awesome.
Yeah. Any other updates from community foundation things?
From the security side, not too much. I will say, to keep in everyone's mind, one of the audits that I would like to get done in the future is a live network. So basically making a test net with auditors from everyone, with nodes from every implementer, and then attacking that live. Because most of the audits we have so far are code audits, and that's great. But as we've seen in the past, some of the bigger bugs we have had come from, live testing. And this is across, we see this in the blockchain crypto ecosystem all over. So yeah. Probably, I think every project is already capable for this, and it's not going to be soon. The auditors I have in mind for it will probably be booked for about 3 months, but in the future, look to be contributing to a fun test net where things are intentionally broken.
That sounds good. That sounds like a good thing to have. I agree. Thanks. Alrighty. Any questions about any of the updates that have been shared? Fantastic. Yeah, so I think we talked about network V13 actors, V5 stuff. Obviously, we can take questions at the end as well. But I do want to get to some of the simulation work that we've been doing. The motivation behind this was basically Hyperdrive really changes a lot of things about the Filecoin network by significantly increasing storage onboarding rate. And so we wanted to see what that would look like and make sure we weren't getting ourselves into any trouble. And Stabelian took on this project, and I can now describe both the work that he did as well as results that we've got so far and how we're feeling.
Okay. Yeah. Here. So basically, I created a simulation system that just generates a fake blockchain, assuming that everyone on the network continues doing what it's supposed to do, and then seal as fast as possible. So basically, just takes any network, forks it at some point, it starts to like perform window posts as necessary. Will create as many proof commits as possible, and create as many seal or pre-commits as possible, and just kind of runs the chain at max bandwidth. So that's the general idea. The idea of okay, like in a month, 2 months, 3 months, 6 months, whatever, what will the capacity be on the chain, assuming everyone's sort of like doing what we expect them to do? Will anything break? What will the stake growth be? That kind of stuff. So now I'm going to share my screen with results. Here we go. So yeah, I ended up creating this work document that describes a lot of the results. In terms of their data store size, this is purely Lotus things you might not care too much. We noticed that before the data store is growing about 21 gigabytes per day. Now it's going to grow around 23 to 24 gigabytes per day. So we're not actually increasing the churn too much in this new network version. The sort of headline is the state tree size. I actually have two versions of simulation here. One is assuming that the network is optimal. That means basically 5 blocks per tip set, completely full of messages, no gas overestimation. This is not realistic, but it shows like, well, worst case scenario, what happens. And the answer there is that the state tree grows 1.7 gigabytes per day. This is rather a lot. But we do have other improvements on the horizon to improve the situation before it gets too far out of hand. But we figured we should share this with you. Yeah, now if you look at more realistic numbers down here, I basically modified the simulation to take into account the overestimation we're seeing on chain and the actual block efficiency or chipset efficiency we're seeing on chain. So you can see the lines are kind of tapering down a bit in say tree growth. We're getting about 1.1, 1.2 gigabytes per day. So it's still large, but not too terrible. From there, we can project and see how big state trees will be and also how big the actual snapshots will be. So as you probably know, most people restore their nodes by or start up by like loading snapshot in basically 6 months. The state tree size and the snapshot will be about 1/4 of a terabyte. We're hoping to have improvements by then, or at least by the end of the year, because like there are people that are working on improving this. The biggest contribution that we've seen here is actually sector infos. The biggest part of that is the COM-R. So the only real way to tackle this is to move COM-Rs off chain, which is a goal. It's theoretically possible. It's a bit tricky because it means we have to change how window post proofs work, but it is still theoretically possible. There are other changes we can make. For example, we can probably slim down the sector infos by quite a bit. There's a lot of duplicate information in there that's kind of present in all sector infos, where if instead of storing everything as kind of like one, like separate objects, we kind of turn everything into a column store effectively, where we have like one column of COM-Rs, and then we like bit fields for like everything expiring with certain epochs and all this kind of stuff. We could probably shrink the state by, I'm guessing, about a half, which is not going to really fix the problem, as you can see. That means basically in a year we'd be at a 1/4 of a terabyte instead of half a terabyte. But that, like, if necessary, that's a wrench we could throw at the system to improve the situation. We also did a bit of a bit more analysis on snapshot sizes, and trying to figure out, okay, if we were to try to slow this down, what ways could we try? So for example, we said, okay, if we wanted to target 100 gigabyte snapshots, how would we do this? We'd need like a slowdown factor of 4.5x on the new chain. And then we just looked at different targets. I'm not sure if anyone's interested in discussing this, I can later, but it's not too interesting. But mostly we looked at like basically increasing gas and or reducing batch sizes. So one of the most effective approaches we found was just we could in theory reduce the batch size. At the moment, we're not planning on doing any of this. At the moment, we're planning on just saying, okay, we discussed this, full steam ahead. The state tree is going to grow, but we have plans for improving the situation in the future. And it does meet our goal of faster network growth. So things working quite well. We can also look at onboarding rates. These are all projections here, but let me get down to the actual simulation results. These simulation results actually come from before I adjusted the gas usage. So it's a bit unrealistic. Here we're seeing 800 petabytes per day onboarded. In practice, there we go. This is the new power growth at the top here. I still need to import this into the document, but it's more like 540-ish petabytes per day. But that's basically what we're expecting. Currently, we're seeing about 50 petabytes per day onboarded. So we're expecting about a 10x increase or 11x increase in onboarding bandwidth. In case anyone's interested in how the simulation actually works, there is a PR that I can probably find if I go to, let's see. No, well, apparently I don't have the PRs synced. Take a look at the feat/Lotus Sim branch in Lotus. You can find the current work here. It's something you can probably replicate it in other systems and other languages. This is specifically designed though for Lotus, so we can test like how Lotus sort of holds up. But if you're interested, you can probably take this code, generate a chain in Lotus, and then effectively copy the chain into like your system, and then just see does that, can you validate that chain? There are a couple of hacks that I have here where, for example, I'm not signing messages because I don't have the keys. I'm sending everything as SecP messages instead of SecP and BLS because I need a deterministic execution order. I only have one massive block per tip set instead of the actual 5 blocks per tip set. So there are a couple of things here that aren't quite correct that you would need to fix if you actually want to do full chain validation. But it's enough to actually basically test your actors implementation and test performance and that kind of stuff. Then I guess that's it from me. Any questions?
Yeah, I've got a few questions, and I'm sure others have too. Just right from the start, you were talking about the difference between state tree growth and churn, and the change in churn. Do you want to elaborate on what that difference is?
Yeah, so basically, state tree growth is state that's permanently added to the chain. Churn is state that's added and removed, or just changed. So a lot of the churn comes from window post, where basically every deadline you submit your window post, the window post proof gets stored for some period of time. That changes the deadlines, adds a little bit of state, the state disappears, that kind of stuff. We're seeing this is about 20 gigabytes per day, 21 gigabytes per day of just rolling churn. This is also what can be effectively garbage collected, or if you restore from a snapshot, you don't necessarily need all of the historical states. You can throw this away. That's what the churn is. The state tree growth, I'm specifically working on the state you need in a single state tree. That is the more annoying part about this. Means if you want to have the full state, you want to be able to validate blocks, you need the full state tree, and then you need basically the churn back through 1,800 epochs. That is a current snapshot size, but you don't need the churn beyond that.
So even if I were to say I only care about the last 3 days of what happened in the chain in the last 3 days, this is still going to impact me significantly because it's the state tree size itself that's getting a lot bigger.
Yeah.
Gotcha. And you also mentioned that a lot of this new state is COMRs in sector infos. What's a COMR?
COMR is the sealed sector CID. That's basically it. It's I think it's 36 or maybe 38 bytes or something like that, maybe 40 bytes. I don't know the exact size. But when you're sealing, I actually haven't counted the number of sectors per day, but a lot of sectors per day. this starts growing pretty quickly. That's the problem there. And it's a hash, so it's not something we can even compress.
Excellent. And you did, like, obviously the simulation was kind of Lotus based, and a lot of these numbers are in some sense Lotus specific, but is it fair to say that like any implementation of the Filecoin protocol is going to experience something similar if the numbers are the same?
Yeah, so the state tree growth is not Lotus specific. That is actually, I was measuring the size of the state tree itself. There will of course be overhead in your data store. So actually my measurements there are probably significantly lower, unfortunately, than the actual values. It might be about, well, probably not quite 2x, but you do have to store the extra metadata, the CIDs, whatever else you need to actually like index the data, basically. The data store growth is somewhat Lotus specific, but again, you should expect the same order of magnitude in any other system you have. Yeah, the power growth is going to be, or the capacity growth is going to be the same everywhere. I actually also have numbers on window post submissions. We're trying to project and see like how much of chain bandwidth will window posts take as we add more and more state to the system. Currently, these are kind of the numbers I was seeing over time, where every day it was growing by about 0.05%. So like it's something, but it's not too much. And we have ways of improving this. Like there are optimizations we can make the window post specifically. We've also been discussing again ways of just sort of super linearly optimizing window posts. So like basically the big constraint on window posts right now actually is the fact that to verify a window post, you need to load up a bunch of sector infos from the chain. You only need this for recovering window posts and disputing them because they're not verified for normal submissions. But still, like this kind of limits the maximum, effectively the maximum of sector infos we can load up, because we can't load up too much more in a single block. So we want to be able to fit window posts in a single block. In this release, actually, we are increasing the number of window posts we're allowing in a single block. The number of partitions we're allowing per window posts, which should decrease the bandwidth used by these window posts. But like there's kind of a hard limit there. However, like for example, if we were to be able to not store the COMRs on chain, part of this process would be making the window post not need to load the COMRs. This gets a bit tricky because it involves like doing fancy things under Snark probably to combine the COMRs into some kind of Merkle tree. We don't know exactly how this is going to work out, but we have people thinking about this. But in theory, you could basically submit a window post that doesn't need to really load any state, except for maybe like some like root COMR, like aggregate COMR for the entire partition, and we just verify that. So that way we could submit window posts and basically limit the number of partitions instead of the number of sectors.
Makes sense. Thanks. Sorry, yeah, who else has questions? Monopolizing the time.
I have some questions with respect to the growth of the state. So you're saying currently right now the state growth is around 1 gig a day, the state tree?
No. After the simulation, like after the upgrade, it'll be around 1.2 gigabytes per day. Currently, it's significantly less. I haven't actually measured that yet. But the current state tree size is about 16 gigabytes. And this is the sort of the accumulation from like the entire network over the course of it so far. So it's significantly less than 1 gigabyte per day.
Okay, yeah, that's what I had thought. Okay, I guess I just misheard. Yeah, okay, I guess that's all.
Yeah, sorry, I still need to measure that, but it takes time to measure the state tree size.
Yeah, that makes sense. I just see, yeah, it's a little bit concerning if it's going to be a gig a day. I'm not sure how people are going to download these snapshots in like a month from now.
Yeah, I think that's like, it's concerning, but I think like in terms of download time, you can kind of like download the snapshot, like especially if you're trying to like roll your data store or like garbage collect it. We have a couple things here. One, if you've seen the split store in Lotus, this is kind of a way to allow you to like do local garbage collection, where basically you keep your hot store of like the thing you actually need and your cold store of everything else. and then if you run out of space, you just delete your cold store. This should reduce the amount of times people actually need to download the state tree. In terms of actually like spinning up a new node, yeah, you're going to need to download basically like 10x the amount of data within 6 months, but or actually more like 8 months. That's not great, but it's not the end of the world with most people's bandwidth. Like one thing we'll definitely need to do is make sure that like these like snapshots get distributed around the world. So no matter where you are, you can download the snapshot without having to cross countries and firewalls. Yeah, it's also beyond that. Like I think this really motivates like client work. It's already really difficult to use, or sorry, to run a Lotus or any other Filecoin node locally, just because of like the chain verification and storage requirements. This just makes it even more important to have a like client system. Yeah, I agree. This is scary, but we do have planned optimizations and ways to deal with it. And we'd rather not get into a world of like sort of arbitrarily limiting ceiling capacity. That was basically the decision there, at least from our team.
Hi, Steven.
Yep.
Yeah, this is fantastic analysis. I think it's a very good simulation. Yeah, thank you. Yeah, is this public available? Yeah, would you please share a link of this? Yeah, if it is.
Yeah, I can probably do that. It's not currently publicly available, but I think I can add people who are here. I just haven't, like, this is kind of a living document. It's not really ready for people, or like for lots of random people to come in and ask questions, but I think I can share it to the people in this room. Is there a group in the Filecoin project, Ayush?
Yes, full implementers.
Okay.
Is people in this group. Also, we will definitely be including some of the results that come from this once they're like cleaned up and formalized a little bit in like the release notes and general comms around Hyperdrive, because we definitely want people to be aware that this change is going to be happening and no one should be caught by surprise if hardware racks and so on are going to go up. We'll try to be as explicit about that as possible.
Yeah, understood. Yeah, and I have another question that is about just as you mentioned the size of all the states is growing very quickly. So you mentioned that we could have the common R data of chain offline. So I'm thinking and about this is because every miner needs the common R data to verify the proof actually. So what's the difference between to put
currently? So yes, like that's why it's tricky. The goal here would actually be to make it so that like the commars are off chain, but there's some form of witness on chain or aggregate witness. So the idea is that like when I submit a window post, that would instead of like you have it like sort of or a verifier having to load up all the commars from disk and then use that with the window post. Instead they would load up like some kind of Merkle tree root that includes all these commars, and then the window post will actually prove using this Merkle tree root instead of the individual commars or something like that. That is just an idea of how to make this work. But you can have a system where even a verifier of one of these proofs doesn't actually need all of the local commars. They just need like some witness of all of them, some like chain of events showing that yes, this witness was built correctly, that kind of stuff. Now, the miner creating the proofs will still need all the commars. So like miners will need to store their own sector infos on their own local disks. This becomes a bit of a problem for like if you lose data restoring things. So this would need to be like well kept and backed up. I think that the commars are already stored probably redundantly inside the sector, like the other sector state locally, because like, or you can also even regenerate it if you need them. But yeah, does that answer your question?
Okay, yeah, very good. Thank you.
Yeah, I also just want to say that, like, yeah, this is certainly something of a gnarly problem, but I think there's scope for a lot of creativity to come up with clever solutions to address this. So folks here want to think about it. If you have a cool idea, like, let us know. Full implementers are open to it, because I think there's the range of the problem is hard, but the range of solutions is very wide, and so as many solutions as we can think about and consider will help here. And
again,
an effort over the next few months, I think.
Yeah, again, there are also shorter term solutions that involve things like, again, like just shrinking the size of these sector infos, because they include a lot of things like projected network growth and like things having to do with like fines and stuff like that. And like a lot of these fields can probably be sort of like linearized into their own arrays. And if we sort of rotate the entire data structure and data store, we could probably save half. Unfortunately, those things are only going to be like linear factors instead of superlinear factors, and we really need to like in order for this to really continue to grow properly, we need to like store on-chain state sublinear in the number of sectors.
But there is enough scope for linear improvements that I think we can stay ahead of the problem moving forward. Cool. Any other questions? I have a question about the simulation work itself. Like, how extensible is this? Like, what use can we get out of this moving forward?
Actually, one of the nice things about it is it does just kind of run everything forward. So I would like to use it to like test things like expiring sectors. And what happens if a miner just like goes off the network? What does it do to cron when it has to like terminate everything? Like, how does the network deal with terminations? Like vaults and stuff like that as well. The cool thing is you can kind of just take a network at any point and fork it off, perform whatever upgrades you want, and then just sort of continue running it forward. So this gives a lot more information than we usually have when we're trying to do an upgrade. Yeah, the main limitation is like this is mostly built within Lotus, because the goal was really to test like how, or one of the key goals was to test like how Lotus would react to this upgrade. But it's pretty pluggable. So like if I look at basically you define it with this pipeline, where in this case I have the first thing is a funding stage. Is basically like I need to be able to fund myself when I'm running simulations. So I have a stage here that kind of just like takes money from large wallets and pulls them into a single wallet, so I can actually fund messages and fund miners. The next one is a window post stage that just goes through and like figures out any window posts that are like that can be submitted at this epoch, and then tries to submit them. Then in the remaining gas is a proof commit stage that proof commits any pre-commits that are now ready, so that have passed their 150 epoch delay. And then finally, this pre-commit stage that basically just takes the rest of the chain bandwidth available and tries to submit as many pre-commits as possible. But you can change this. So for example, we can add additional stages in there that allow you to send arbitrary messages. We can add a stage that just like is a kind of a chaos monkey stage that just randomly restores and removes and fault sectors. At the moment, unfortunately, this is kind of like when you run the simulation, you kind of run this separate binary and say run. If you want to analyze it, you shut it down and run your analysis. I would like to eventually have this running as a daemon, so you can just kind of have it like running as like kind of like a normal Lotus daemon, and then you can make normal queries and submit messages that way. But we're not there yet. But it should be pretty sensible.
Interesting. How comfortable are you, / how accurate do you think that like queued approaches of like, let's get all the posts in that may be interested in getting in at this epoch, then let's get any proof commits that are ready, and then we'll just fill in the rest. Like, how realistic is that?
It should, like, the ordering is a bit different, but in terms of like, it's not perfectly realistic. So like it might be slightly underestimating the churn actually, because usually you probably have pre-commits on chain for a longer period of time. Although actually that wouldn't increase churn. It might basically, there might be a static bump to the state tree size, not a bump to the state tree growth, but a static bump to the state tree size due to like more pre-commits on chain. The reason I did it this way is like otherwise I basically need a bunch of sort of separate like agents all pretending to be different services and all trying to reprice things. And I just wanted it to be very deterministic and easy to analyze and understand. So like, yes, it's not 100% accurate, but I think it is pretty close to accurate, and it does show you like if the network were behaving optimally, like how much bandwidth would be used for window post, how much bandwidth would be used for like each one of these things.
Yep, that makes sense. And that is a good flag to bring up. With at the end of the day, the simulation is making a lot of assumptions on how much demand there actually is for storage onboarding and so on. We'll see what actually happens post hyperdrive. We don't know what the increase in onboarding rate will be because of real world factors. So
yeah, I assume it's not just going to like instantaneously jump up to 10x or 11x. But yeah.
Yeah, thanks a lot. This is very cool work. It's very cool to be able to see all of this. Any other questions? Cool. Nice thumbs up and clap emojis. Cool. Any other questions or points of discussion that people wanted to bring up about anything Filecoin and hyperdrive related? All right. Sounds good. I think we can wrap up here. Take any questions or thoughts async in the Film Influencers channel. But for now, bye everyone. Thanks for joining.
Bye.
Thank you.
Thanks. Yeah.